Okay, so now we will start to revise topic 2 lah, atomic proton number, neutron number, isotope, at least. Okay, so for this one, this topic is quite simple. We should go for a question because the question, if we need the information, then we go back to the short notes that. So look at this one. What is mean by isotope? Okay, so this definition you may not have to have out. That isotope is atom of the same element. Means example, all this is actually oxygen, so they all are same element, have the same proton, number of proton. Okay, so for example, in this case, it has 8 proton, 8 proton, 8 proton. Then this one, 16 minus 8 will be 8 neutron, 17 minus 8 will be 9 neutron, 18 minus 8 will be 10 neutron. Okay, so they have same proton number of proton, but different number of neutron. Okay, so this is the first answer. Or you also can change it to this one. They have same proton number. Okay, this is my proton number. This one will be my neutron number. Remember, you either write same proton number, different number. If you write same proton number, then you must write different neutron number. If you want to write same number of proton, then you must write different number of neutron. You cannot like, if you start with number of, must same number of, then different number of neutron, that is. You cannot write same proton number, different number of neutron, then it's not accepted. Okay, it's either these two pair or these two pair. Okay, two information that can be driven from oxygen 18. So now we focus on oxygen 18. What information we know? First, the proton got proton number is 8. Then the neutron number is 18. Determine the number of neutron in what we call the oxygen 18. So oxygen 18, we have 10 neutron. So it's the 18 minus 8. What is the electron arrangement for this? Okay, see, when you 8 proton, you should have 8 electron because proton and electron are the same for the atoms. Okay, so 8 will be 2.6. Okay, what is the difference between physical property of 16 and 18? Okay, so you see, you can, because they have different number of neutron, and you know that proton, the mass is 1, the neutron, the mass is 1 also, electron, the mass is 1 over 1840. So technically, if you have different number of neutron, your mass will be different. So when the mass difference, right? Okay, when the mass is different, mass over volume is your density. Also different. So if this one different, your density will be different. Then if your density is different, your melting point and boiling point will be different because denser, let's say your mass increase, density increase, your melting point, boiling point increase, because if you have higher density, mean all very packed together, to boil, to melt it will take longer time. Okay, so this is the things, the potential difference, that melting point different, boiling point different, density different, or the atomic mass also different. But for all this isotope, right, they will have all same chemical property. What does it mean? Whether it's oxygen 16, oxygen 17, oxygen 18, right, they all will react with oxygen to become a carbon. They all will react with carbon to form carbon dioxide. Okay, because all of them is oxygen. Okay, now, so when they ask you, of course, K-part question, they won't ask you directly. This is how they ask you. Will all this oxygen react the same way when they heated with iron? So when all this react with iron, right, of course, they will react the same way, means all will become iron trioxide, that is. So this is your explanation. So they all have same chemical property because they all are oxygen. Okay, then oxygen, the chemical property actually all depends on the valence electron. So because all of this, the valence electron is 2.6, 2.6, 2.6, whether it's oxygen 16, oxygen 17, and oxygen 18, the all electron arrangement is 2.6, 2.6, means their valence electron are the same. Okay, then chemical property, chemical equation between carbon 16 and carbon oxygen. So carbon plus oxygen 16, it will become carbon dioxide. Okay, draw the atomic structures of the oxygen 17. So this is how it looks like. That electron ratio is 2.6. Then after that, at the middle there, you have 8 proton and 9 neutron. Okay, then isotope are used in many field that which is medical, industry, agriculture field. So state one of the uses of the isotope in each this field. So first thing you must know that the copper-60 used to treat cancer. Actually, school exam or even SPM, there are few isotope they always ask. So if you do a few questions, you realize, hey, the isotope they ask is always similar. Okay, example, you need to know copper-60, they have very high radiation, so you're able to kill any cell. So we can use it to kill the cancer cell. Then industry, you can use the sodium-24 to track the leakage. This is the one that's very popular in exam. Then agriculture, phosphorus, we always ask in the exam also, is to use to study the metabolism of the plant. Okay, so this is the typical one. Okay, then after that, about this thing, they'll ask you to find the relative twin mass for the magnesium. So what happened here is this is 79% of magnesium 24. Then you have 10% of magnesium 25. Then you have 11% of magnesium 26. This one got some typo here. So how we calculate is very simple. We just take the average of 79% times 24, 10% times 25, 11% times 26 divided by 100. You get the average mass. Okay, this is a very simple calculation. Then we try on this question. What is the what is the number of electron in atom T? So this atom T got 19 proton based on this number. So means you got 19 electrons. So 19 electron, how do you arrange? 2.8.8.1. Number electron, they asked for number electron, so it's just 19. Then what is the neutron number of T? Neutron number of T is 39. Okay, which pair is isotope? Now for isotope, right, you need to find out they have same proton number, different neutron number. So this one will be your S and U lah. Then state one use of this one. Okay, for this one is carbon-14. So you remember carbon-14? Carbon-14 is used to detect the age of the fossil, but you have to write estimate because we only managed to estimate how long this animal die, or that we only can estimate that he died maybe 1,004 years to maybe 1,005 years at least. We can estimate the range. We cannot determine the age. Determine age means we know this bone. Okay, this animal died like 1,475 years ago. This is called determine. Okay, so we only can estimate around 1,004 to 1,005. So in exam, you write determine will be wrong. Okay, so one difference between the physical property, as I told you, isotope, the physical property difference will be the mass, density, melting point, all this. Okay, then reason is because they have different number of neutron. So draw the electron arrangement of atom R. We check that. Atom R is this one. 11 proton means 11 electrons, so 2.8.1. So you can draw the electron arrangement 2.8.1. Then okay, now this is questions. For the mass, right? Proton, neutron, and electron. So proton is 1, neutron is 1, electron is 1 over 1840. So technically, yeah, this is almost equal to 0. My mass, right, will be focused on proton and neutron. And proton and neutron, proton plus neutron, so happen that is equals to neutron number. So technically, my neutron number is equals to my mass number. So to know the mass of R is very simple. You look at this number. The R, the neutron number is 23, means the mass also 23. Okay, this is the hidden information in here. Okay, the R, the relative atomic mass will equals to the what we call the neutron number. Okay, so now we know R, the mass. Although here they didn't mention to you R is what is the mass, but you should know it's equal to your neutron number. So R, the mass is 23. Okay, R20, what is the mass? You just write out. R got 2, so 2 times 23 plus O is 16, so it's 62. Molar mass is gram per mole. If they ask for relative molecular mass, because this is a molecule, then it's equal to 62. Because relative molecular mass is like I compare with 1 over 12 carbon, the mass. So comparison is like no unit. It's just how many times heavier. But for molar mass is different. Molar mass means the mass of 1 mole of substance. Means you must tell me how many gram per mole. Per mole means every mole, how many gram. Okay, same thing. Isotope I use in medical, industry, agriculture, and the archaeology. So this is the answer. That copper-60 can use to treat cancer. Phosphorus-32 absorb of the fertilizer of plant. Then carbon-14 is used for estimate the age of the fossil. So then 24 to track the leakage in pipe. So as you can see, the question, you know need the half hour all the uses of the isotope, but the question, that's why I say sometimes chemistry, you have to practice a lot of questions. They actually, the syllabus maybe 100%, but normally frequent common exam will be 20%. So you need to practice a lot of questions. So this blurb book, we have about 40 over questions. So we can try after order for almost 40 questions, you should be quite confident for the first time exam. Okay. Then you try on this one. Okay, so for this question, right, proton is positive, electron is negative. So technically, this is all the plus. This is all the minus. Okay, this is neutron. Okay, proton, electron, neutron. So positive ion, the positive must more than negative. So which one is positive ion? It will be this one. Okay, which is my G. Okay, it is 2 plus. Then negative ion is the negative more than positive. So we check here, negative more than positive. Negative more than positive. So we have 2 C and F. So which two particles are atom and ion of the same element? So we check here. Which element will depend on proton number. So we check here, proton same number, but one is ion. So example, this is ion because this is the ion. This is atom because proton and neutron, proton and electron are same number. It's neutral. Okay, so it's C and D. Which one is neutral particle? We check here. Neutral particle, this one neutral, neutral, neutral. So you have 3 neutral particle. Or one more. Yeah, for this one. This one also neutral. Okay, then which particle have the complete valence shell? Okay, complete valence shell means the shell is full. So we have to check one by one the electron arrangement. So this is 2, 2.2, 2.8, 2.6, 2.2, 2.8, 2.8.8. So complete shell will be all of this stuff. Is already full shell. So we have 4 particles that have full shell. Then we check on this one. Which one of those atom or ion had the greatest number of the electrons? So we check here. This one I have to do one by one. This one got 26 proton. Because it's 3 plus, so the electron will be 3 lesser electrons. Okay, so this is the electron number. This one got 30 proton, 3 plus also, so the electron will be lesser one. Because 30 plus and 28 minus, so the charge will be +2. Okay, this is neutral, so 25 proton, 25 electron also. This is 19 proton, and then plasma, so means the electron lesser one. Okay, this is 3 proton, 3 electron because it's neutral. So which one have the greatest number of the electron will be this one. Then after that, which 2 have the same number of neutron? Okay, same number of neutron with the minus of it. So 56 minus 26 will be 30 neutron. 65 minus 30 will be 35 neutron. 55 minus 25 will be 30 neutrons. So technically, we found these 2. And after that, state the number of electron in the 56 and 26. So we already told you here, 23 electron. Greatest mass. Greatest mass, you have to check this number, the mass number, the neutron number. So greatest mass should be this zinc. Okay, what is mean by isotope? Either you write proton number or neutron number. Which one is isotope? So we check here. These 2 are same proton, different neutron. So this will be the answer, W and X. So oxygen 16, oxygen 18, oxygen 17. What is the difference? So you can write the proton, number of proton are the same, number of neutron are different. Then the chemical property same, the physical property different. Then percentage of abundance, we have this one 5.85%, 91.75%, 2.4%. So you just times in, you get the answer. So percentage times mass, percentage times mass, percentage times mass, divide by 100%, you'll get your average mass is this one. Okay, then we move on to this one. Okay, this one is a thinking question that it don't give you the 180% of 11, but I don't have the how many I've got 20% of unknown mass. So how do you get this mass now? They tell you the average mass is 10.81. So this is what we do. That you take the 10.81, then this is 80 times 11%, and then what unknown I just put as y, then divide by 100%. So from there, you'll find your y is equals to 10.05%. So the mass will be equals to 10. Okay, so because normally how we do the question is we take the 80 times 11, 20 times the mass, but since I don't know the mass, I put as y. So 80 times 11 plus 20 times y, divide by 100, I should get the answer. Okay, so this is the idea. Then move on to this one. Okay, what is mean by isotope is the same. Similarity and differences. So the similarity will be the proton number of proton, number of electrons the same. Difference will be the number of neutron, and the nucleon number is different. Then this one is a thinking question. Phosphorus form a simple molecular mass, molecule that have molecular mass, related molecular mass of 124. So suggest the formula. So because unknown molecule means it's possible to be P1, P2, P3, P4. We don't know what is the size. So you write Pn first, means unknown, and the mass is 124. Then the mass Pn equals to 124. Then we put in the mass of phosphorus, 31. We will get N equals to 4. Then you put back the formula. If you put the 4 inside, it becomes the P4. So this is the formula. What is the two different physical properties? As I told you just now, it's the same melting point, boiling point, atomic mass, density. Will they react the same way with oxygen gas? Yes, because they are isotope, they have same chemical property due to they have same valence electron. You can see the question is repeating. Okay, what is the use of isotope to study the fertilizer of the you can use as fertilizer. So this one also same thing. We've got 19% of the 10. 80.1% of 11, then you find the mass, you get 10.8. Then this one we have two data. One is sub S32, and one is this one. Since we know the mass is 30.1. So how do you get the mass? Right, it's very simple. If this is X, if this is X%, this one will be 100 minus X%. Because total percentage is 100. So imagine if X is 40%, the other side is 60%. How do you get the 60%? Is 100 minus 60. Then you get 40%. Okay. So these two add up together should be 100. Okay. So how to find the mass? 32 times X. Okay. Because the mass is 32, the percentage is X. So 32 times X, then plus the 34 times 100 minus X. Divide by 100, you should get your this number, 32.1. So you add inside, then you're able to get your y equals to 95. So y equals to 95. The next thing you need to know, your 32 is 95%. 34 will be 5% because 100 minus 5. 100 minus 95 will be 5%. Then here's the last question you can try. Relationship between P and Q, we check here. The proton same. Then the neutron different. This is isotope. One similarity, differences. So you can write similar chemical property, different physical property. Okay. So one similarity of particle PQR. We check here. PQR, the similarity. You can see the electron are all same. 2, 2, 2. Okay. So 2 valence electron. Okay. Then after that, does particle R has similar relationship with P that react the same way when P and Q in A1? Okay, the main thing is R, is it isotope of P? So the answer is no, because their proton, here got 2 proton, here got 3 proton. They actually is not isotope. Then this is the mass time. 50, the mass 50 is 44.3%, 52 is this percent, 54 is this percent. Then you calculate the mass. They say got 4th isotope. So there's 4th isotope, that's X, X percent. Oh, the mass is X. Then the percentage is how much? You can take 100 minus this 3 because the total percentage is 100. So you calculate the percentage should be 9.5. So 9.5%. But the mass is X unknown. So now you take out everything times together, then 9.5% times Y, then you get your Y is equals to 53. So the mass is here, 9.5. It's very similar to those mathematical questions.